Okay. So just to reiterate for any new people here, trigger warning, AI is just a stack. It is not magic. It is not going to destroy the world. It is simply yet another stack in technology. To go with the joke, the stack is dead, long live the stack. That's basically what our career is. It is interesting just to be thinking about this. So for me, again, when I got my MCSE, it's something called NT 4.0, literally 1 year after I got my, or less than 1 year after I got my MCSE, they were already doing the MCSE 2000 boot camp. As I was in that, I was in one of the first MCSE 2000 boot camps held in the United States. 1 month into my boot camp, they were already talking about Windows XP. Like, that is how quick things were moving 20 some odd years ago. And so something just to consider now is a lot of people started using JavaScript and got on the JavaScript stack like 15 years ago. And they kind of think like that is technology. They're like, this is the stack. And it's like, no, it's a stack that has lasted a really long time. Even the creator of JavaScript questions why the hell JavaScript is still being used, which is a hell of a thing, right? So just realize, like, when you hear like JavaScript jobs going away, that is not the tech industry, that is JavaScript. Because again, even the creator of JavaScript thinks it should die by now. Okay, let's see here.
There will only be another framework in 6 months anyway.
What's that?
There will only be another JavaScript framework in 6 months.
Yeah, JavaScript. Oh, anyways, JavaScript. Anyways, I have my own things with JavaScript. Setup. So if you want to be doing the things today, let's see, just so you know, again, when we talk about computers and we talk about resources, people think you need the latest and greatest computer. It really depends on what you are running on your computer. Python 3, so the main programming language that we're going to use, can run on a potato. This thing can run on a Raspberry Pi. It doesn't matter what kind of computer you have. SQLite can also run on a potato. It doesn't matter what kind of computer you have. And if you use API calls, when we talk about things like architecture, if your computer is communicating with somebody else's resources and bringing down the response, that can also be done with a potato. So you do not need a powerful computer to do almost anything that I'm showing you today. The one thing that you may need a decent computer for is this thing called the Ollama framework. So we had a class on Ollama about a month ago, 2 classes ago. That actually runs locally on your system, and depending on what model you run, you may actually need some resources for that particular model. So that's just one of the things to be thinking about this, because a lot of people are like, oh, how many tens of thousands of dollars do I need for my AI computer? And it really depends on what the hell you're doing. Let's see here, Ollama. If you're interested in downloading Ollama, so most of the examples today we're going to be using Ollama. You go to ollama.com, you download the framework. There's a module for Ollama, so you do Python 3 --m pip install Ollama, and then you actually have to run the model on your computer. So it's Ollama run whatever the model name is. So we use Pi3 in these classes, PHI3. This comes from Microsoft. It's a really small model that gives you some really quirky results. Basically, it'll run on a potato, which is great, but you'll get potato results. That's just one of those things to keep in mind. If you have a decent computer that can actually run it, there's a model called GPT-OSS. This is the OpenAI's model. Actually pretty darn good, but again, it will be slower and you need enough resources. This is the type of thing you just play with. You install Pi3, see how it works, install GPT-OSS, see how it works, and you decide what you want to do. Let's see here. If you want to use OpenAI, you do need the OpenAI key. This is, again, we had a class, last class actually. We had a last class on this. You go to openai.com, platform.openai.com. You come to the OpenAI page, you go to your dashboard, you get an API key, and you create it here. Basically, you have to plug in your credit card number, that type of thing. This is what will get you the API key. We only have one example using this today, but just to give you that overview. And then SQLite. SQLite is part of the Python 3 distribution, so you do not need to install it. You just run it. And for modules, the only module we need today is something called requests. And so if you want to install the requests module, you can do that. Any questions for basic setup? Just to make sure everybody knows what a potato is. When I say a potato, you don't actually think of russet, do you? No? Okay, gotta be careful. We had a class, my MCSE class, my instructor was talking about if you did some operation that was an illegal operation would fail. And a woman in the class was like, I don't understand. He's like, well, if you run it, it's gonna fail out, it's an illegal operation. I don't get it. And we're all looking at her like, and we're like, what do you mean you don't get it? Why is it illegal? Like, will I be arrested? Like, she literally thought like the police would come. It was 2000. It was a long time ago. So it's like illegal why is that illegal? So I gotta make sure. Okay, so when we start talking about LLMs, the big thing to be thinking about is architecture. The big problem we have when we run into, or when we start talking about artificial intelligence, is the problem of what I call the thing of the name, right? We name something, and then by giving it a name, we associate a whole bunch of attributes to that thing and then assume those attributes to be true, right? So when we talk about artificial intelligence, think about everything you lump onto the concept of artificial intelligence and then just assume that it's there. Again, we had the class on using Ollama about a month ago, a couple of classes ago. And one of the interesting things is the students in the class, everybody was like, oh, well, the system remembers that. I was like, no, but we haven't built a memory system yet. Yeah, but it remembers it. No, but we haven't built the memory system. But no, until we build memory, it has no memory. And so that's one of the big things to be thinking about. When we talk about LLMs, it's very important to say LLMs, like large language models or any of these models, that this is one component of an AI system, right? So if you have a user, they're going to be connecting to your system in some way, right? The first thing that they're going to be hitting is going to be your front end. This is one component of your system. So for us, we use something, again, called the Bottle Web App Framework. And so this basically creates a web app using Python. But in here, this will, you're going to use JavaScript or a framework in JavaScript, maybe something like React. You're going to use CSS. You're going to do HTML. You're going to do a whole bunch of things to create that initial thing that the people are going to be interacting with. Right? Then past that, that's going to go. Again, it's going to go to something called a back-end programming language. And again, most of the time, for us, it's going to be Python. This might be Python. It might be PHP. It might be Node.js if you're one of those types of people. But basically, you're going to have a back-end language that is going to be communicating both with the front end and then all of your other systems. Again, we're going to have a class in the future, 2 classes from now, something called APIs. And so what APIs are, application programming interfaces, is where your code can actually communicate with other people's services and get information. So what is the weather today? What is the news? What are stock quotes? Those types of things. That's going to be coming in from the API. You're also going to have something called data stores. And so what the data store is whenever you're going to have files. So we're talking about JPEG files, MPEG files, PDF files, right? That's going to go into your data store. So if you're using AWS or something like that, that's where you're going to hear about buckets. If you're using your normal computer, that's where you're going to hear about folders. So basically someplace that you're going to dump all of those files. What we care about today is we care about record stores. And so what a record store is simply stores a record, right? So this is where you're going to use a database. We are going to be using the database called SQLite today, which is what's called a relational database. And just to make this incredibly simple for today's class, again, we will have a SQL class going into the future. Basically what you have in a database server is you have the database server, which has a database. Inside that database is going to be tables. Inside those tables, you're going to have columns, so like ID, name, social security number, email address, and then inside this, you are going to have records. So record 1, record 2, record 3, record 4, record 5, so on and so forth. So basically, what the record store is going to do is it's going to store records, and then it's going to allow you to be able to easily retrieve those records, modify those records, do that type of thing, right? So like one of the big things that we're going to be doing today is in the record store, we're going to be doing a caching system. So what's going to happen is you're going to ask the LLM a question. And when you ask the LLM a question, it's going to take a long time. It's going to burn a lot of resources. Remember, whenever you hit the LLM, it is incredibly resource intensive. So the first time it runs, basically it's going to take your request, get a response back, and then when it gives you the response, it's also going to dump that into the database. It's going to put the request in, and it's going to put the response. The next time somebody asks the exact same request, instead of going to the LLM, it is simply going to go to the database, say, I already have that request in here, here's the response we gave before, and as I'll show you, you get it back in a fraction of a second versus having to wait 10 seconds to get it, right? And that's the kind of thing that we're thinking about with these record stores, and this is what we're going to be dealing with today. Any questions on architecture? Basic questions on architecture? No? Cool. Okay, when we start dealing with databases, so today we're going to be dealing with a database called SQLite, which is a relational database. You'll hear the concept of RDMS, Relational Database Management System. This is basically the software that runs your database. So you will hear of SQLite, you'll hear of MySQL, MariaDB, Postgres, MS SQL, Superbase, I guess, is the new cool one that everybody's using. And basically, these are the overall database systems. Now, the important thing to understand is the general language that is used inside these database systems for managing records is something called SQL, Structured Query Language. So SQL, more or less, is going to be the same, more or less, is going to be the same across all of these different database management systems. But what these management systems are able to do, what functionality they have, might be slightly different. Kind of think of it like HTML and web browsers. All web browsers can view HTML, but when you open something in Safari and you open something up in Chrome, they're going to be slightly different. Sometimes Chrome is going to be able to do things that Safari simply can't do, and so that's the basic concept that is going on here with these systems. Again, when you're talking about relational databases, the thing that gets people confused is the concept of the relational part of the database. And so basically, when we've got our database, right, we're going to have tables in the database. So let's say we have a parts table, right? So we have a table called parts. In this table called parts, we're going to have an ID column, we're going to have a name column, we're going to have a description column, we're going to have a price column, and then we're going to have a vendor ID column, right? And so this is going to be our parts table, and then we're going to have all of the different parts, and they are going to be records. ID number 1 is, sprocket. It is a sprocket. The price is $1, and the vendor ID is 25. ID number 2 is a cog. It's very coggish. It has a $2 price, and the vendor ID is number 26 or something like that. The important thing to understand with relational database systems is that every single table only contains the minimum amount of information that it needs to contain for whatever it is, again, with a part or whatever else. You'll notice when we have a vendor ID, we don't say what the vendor name is, we don't say what the vendor address is, we don't say what the vendor email address is, we simply have this vendor ID. Why it's called relational databases is then we have over here, we have the vendor table. The vendor table will have an ID, it'll have a name, it'll have like a contact information, it'll have like an address, right? And so here you have all these records, and so there'll be an ID for 1, and that'll be something, ID for 2, that'll be something, ID for 25, and that will be the Sprocket Co. Located in Ohio with some kind of address, right? So basically what happens when, with these relational databases is with a SQL statement, you do something called a join statement. And so basically you join, when you do a SQL statement, you join parts on vendor ID with vendor on vendor ID. And then what's going to happen is the response that you get back is going to be all of that. So that's what we're looking at when we're talking about with relational database management systems, or relational databases. All of this right here is what is called the schema. So here's the thing. When you were young, when you're 18, when you're brand new to technology, you're going to hate the schema. The schema is going to be the most evil goddamn thing you've ever seen in your life. Every time you have to deal with a schema, you're going to scream and you're going to moan, you're going to whine. After you've been doing technology for about 3 years, you're going to love the schema. It's going to be the most wonderful thing that has ever been created, right? Because, here's the thing with young people don't like to plan. Again, in this modern world of AI, the new stack, remember, as technology professionals, this is what we get paid for. I do not get paid for SQL or Node or PHP or Active Directory or anything else. I get paid for my whiteboard skills, right? Planning things out. And so the nice thing with relational databases is you actually have to plan this damn thing. Now there is a SQL statement called alter table. Have fun with that on a production system, where you can modify these tables on production systems and hope to hell the entire thing doesn't explode. So the big thing is when you're building out your database system with a relational database system, is that you actually plan everything that you're going to be collecting. What is all the information that you're going to be collecting? Why are you going to be collecting that information? How are you going to be joining all these tables? And that's the thing, is you spend a week planning out your architecture, and then you spend 3 hours building it. Young people want to spend a week building it and 3 hours planning it, right? And again, when you're going to be putting this stuff into production, that's a bad deal. That's where you'll hear something called NoSQL databases, which all the kids love nowadays. You hear about something like MongoDB, other of these databases. Those are complicated. We're not going to get into them today. They're a lot different fish. But the thing with them is they're called NoSQL, but they are schemaless. So a lot of young people like to use those database systems because they don't have to do all this planning. Here's the thing, if you're an old timer and you basically do planning because that's what you just normally do, NoSQL's fine, schemaless is fine, you're probably not going to screw anything up. If you're an 18-year-old and you don't have a schema, you're not locked into any kind of system, you can just have a really god-awful database at the end of the day, as everything gets dumped into it. But basically that's the idea of what these relational databases are and why they're important. Any basic questions on this? No? Okay. Is that because there's no questions, or is everybody asleep? Everybody seems to be awake today. Okay, then we get to SQL itself. So I call this SQL. Kids nowadays call this SQL. You will notice I say things like kids nowadays. Again, I do YouTube videos, so I get beat over the head by 18-year-olds that call me stupid. I'm like, I have been doing this longer than you've been alive. But anyways, I call this SQL. I don't know, that's what we called it back in the day. I literally took a class from MySQL back when it was still MySQL, before it was even bought by Sun Microsystems. As far as I understand, it used to be SEQL, Structured English Query Language, back in the 90s. That's what I've been informed. They got rid of the E because it was too many letters, but we all just keep calling it SQL. A lot of kids nowadays call it SQL, so I don't know, you do you. One of the things to think about with SQL is capitalization does not matter. So when you go online, one of the things you're going to see with SQL statements is for like insert, select, update, alter, the commands, they'll be all uppercase. This is uppercase, just like HTML many times is shown as uppercase. It doesn't matter. That is simply being used for your information to make it easier for you to read. Capitalization does not matter. Formatting is not required. SQL can be as ugly as you want it to be, just so you understand. And then the delimiter. So when we talk about delimiters, these are the ends of commands and programming languages, is going to be the semicolon. It's not going to end until you put the semicolon in there. So here, you can see down there, you have my little SQL prompt. So I can do like select all from thread as a database, or as a table. I'm doing SQLite. Select. So this is what SQL looks like. Select. Here, let's see if I put this up here. Let's use Windows. So you can see, I'm on you stupid thing. So maybe you can see that a little better. So select all from thread. So thread is a table. We're going to select all values from thread, and we're going to use the semicolon. When you hit enter, that is then going to print out the responses for you. We're going to show you what this thread table shows in a bit, but we can see answer in under 10 words, hello. And then the answer is, hello, how can I help you today? And then it's going to give a timestamp. So that basically that's the idea of what SQL looks like. Again, we're going to have a SQL class later. This is going to just give you a basic overview. One of the big things with SQL to be careful about is if I do select all from thread, and then I hit enter, you're going to get this. You don't get out of that till you do the semicolon. So that's one of the big things. One of the other things that I'll warn you, so again, whenever you're looking at examples, what they'll do is they'll separate things on lines. So not quite this, but select all from thread. So a lot of times to make it like easier to read, they'll put it on different lines. Now the thing is, see, you can use the up. If you screw it up, if you mess something up, you can do up arrow. But if you do it on multiple lines, each time you're just going to get whatever was on that line, right? So with here, if I put it all on one line, it might be a little bit harder to read, but if I screw something up, I can just go back to it. If I put it on multiple lines, you're gonna get this mess going on. So one of those things to be thinking about when you're dealing with SQL. So with SQLite, any basic questions on SQL? Kind of got the idea there? Okay. With SQLite, so this is its own database management server. So basically its own software, right? So SQL itself, so insert, select, update, alter, drop, those kind of commands, those are basically going to be the same across all the databases, Postgres, MySQL, the whole 9 yards. But the database servers themselves, you have to interact with them in their own particular fashion. So like with MySQL, you use the command describe, DESC. So you'll say like describe the table, describe this, describe that. That's what you do in MySQL. In SQLite, you actually use periods. So if I want to get out of SQLite, the important thing to understand is you do period, exit, and that will get you out of SQLite. One of the big things to understand about SQLite, so SQLite 3 is the command to get into it. Be very careful. So if I simply type SQLite 3 in here, and I kind of forget what I'm doing, because that's what happens most of the time, and I hit enter, you'll notice I get a nice little, SQLite prompt here. The thing to understand, though, is that if all you do is put in SQLite 3, this is creating a temporary database. So be very careful here. So if I now do create table, I create a table, I populate the table, I verify that the table has been populated, I feel very good about myself, and then I exit, all that data goes away. Again, SQLite is great for many things and god-awful for others. So basically, with SQLite, what you do is you do SQLite 3 and then the name of the database that you want to go into. So, and this is where you also have to be careful. If the database exists, you'll get dumped in the database that exists. If the database doesn't exist, it will simply create the database for you, and now you're in a blank database. So again, one of those other things to be very careful about with what you're doing. This can be a big problem too, especially if you're a new coder and you don't really deal with your file structure very well. If you have multiple versions of a database that are named the exact same way and you forget where you're at, and so you drop into a previous version of the database, you do 2 hours of work on the previous version, you just did 2 hours of work on the previous version. So that's the kind of stuff to be careful about there. One of the things too, well, no, I'll get into that later. So, okay, so we do SQLite and we talk about the database and then we get into it. Then there's like the basic commands. So like with things like tables, if I want to know what tables are in this particular database, I do period tables, no semicolon because we're not in SQL. And this will show me what tables I have here. So cache, these are ones we're going to be using today. Cache, memory, picture, OpenAI, rule, and thread. So it's like, okay, I've got those tables there. I'm sitting there, I'm trying to figure out, oh, what does the schema for the picture table look like? I do period, schema, picture. Again, no semicolon because it's not SQL. And then this shows me how I actually created this particular table. So create table, table name picture with a path and a description, and that's how I created that particular table. Any kind of questions about the SQLite commands? Yep.
Is the, so if you're creating a database, is it case sensitive? So let's say you put a capital, name it capital, table 1, and then table 1 without a capital 11. Is it going to bring you into table 1, or is it going to make a new database?
No. Okay, so tables. So when you're in the database itself, capitalization does not matter in the database itself. When you're accessing the database from the outside, it depends on the operating system. Capitalization shouldn't matter, but especially if you're using Linux, it might. Because in Windows, capitalization doesn't matter, it's all the same. Linux, many times, the capitalization. So that's actually going to be like an operating system type deal. So be careful, test. Let's see, some SQLite notes. The thing to remember about SQLite, and again, this is a big thing to be thinking about with everybody wanting to do vibe coding now, as I talk about why we actually get paid. We don't get paid for the SQL, we get paid for the whiteboard, is that SQLite has no security. If we were playing Dungeons and Dragons and we had a character sheet for SQLite, it would have an armor class of -5,000. If the dragon thought about the database, it would keel over and have a heart attack. That is literally how little security this thing has. You can literally open up a SQLite database using a text editor. It is that insecure. You can copy and paste the entire database and then simply open it up from the command line as I showed you. So there is no security at all with SQLite. What I like about SQLite is there's no administrative overhead. You don't have to install SQLite. You do not have to create user accounts. You do not have to create privileges. You don't have to do all this administrative tasks, but it's also because none of those administrative tasks exist. So SQLite is great for testing purposes. You know, if you're pulling information from sensors, any kind of non-secure information. Again, literally, if this stuff got posted onto Reddit, would you care? Hey, look, you got the temperature stats for my house for the past 5 years. Really don't care. On the other hand, there's information out there that you might care about. So that's where you have to be careful with SQLite. With creating tables, if you know anything about databases, especially with like MySQL or Postgres, one of the cool things with creating tables in SQLite is you do not have to specify the data type. SQLite AI? You are late. You are late, late, late. We would fail you. You'll get so many Fs. You get all the Fs. But we don't actually give Fs, so here you go. That's the nice part about not having a grading system. I can't fail anybody. Okay, so when you create tables, so normally there's something called data types. Again, new people in the tech world hate data types, old people love data types. Data types is basically what kind of data is going in. So you'll hear about ints, these are whole numbers. You'll hear about floats, these are decimal point numbers. You'll hear about text or string, this is text information, characters, timestamps, all of that kind of stuff. So normally when you're dealing with databases, they care about the data type because remember garbage in, garbage out. One of the things you have to be careful about, let's say you had an inventory control system and so you're having parts and you sold 20 of this part and 50 of this part and Bob of this part. What would happen when you try to average that all together? How many parts have you sold in a day? You know, 12 by 25 plus Bob divided by 3 equals what? So that's normally why you have to deal with data types. Data types are very important. Data types can be very important too with numbers, the difference between ints and floats. Think about this, you're dealing with prices. You screw up, you put a data type of int for prices, all of a sudden, all of those cents get taken away whenever it gets stored into the database. And so the 50 cents, the 25 cents, the 75 cents, and 99 cents, that all disappears. You're only tracking the whole number. That can be a bad thing. The thing is with SQLite wants to make things really easy. So you literally do not have to state what the data type is. You actually have to go into something called strict mode to even force it to understand the data type. So if you take a look at this page, page 6, all right. So here on page 6, this is the nice part, right? Create table, name of the table AI, I want request, I want response. That is literally all you have to do to create a table. Again, for testing purposes, that kind of thing, this is really great. In production, it sucks. Something to be careful about with SQLite. So you can go into this and you can do request as text and response as text and something else as timestamp. If all you do is define the data type and do nothing else, that's only informational as far as SQLite is concerned. You can still put Bob into the timestamp. It's weird how SQLite works. Basically, if all you do is put the text or the int or whatever in here as a data type, that is for your informational purposes only. You can still dump whatever the hell you want in there. There's a command you can add called strict at the end. So if you create the table and then add strict at the end, that will actually strictly enforce the data types, and therefore you'll actually get the failouts when you're expecting to get the failouts. So that's one of the things to be cautious about with SQLite. The other thing with SQLite is row ID versus auto increment primary key. So normally when you're dealing with MySQL, Postgres, that type of thing, you're going to have this ID column. And so one of the big things with databases is every single entry in the database has to be absolutely unique in some way, shape, or form. And so normally you have this thing called the primary key. It's normally just simply going to be called ID or something along those lines. You're going to auto increment. So every time there's a new record, you will simply increment the number by 1. Therefore, even if everything else in the record is the same, at least the ID will be different. So it will be unique. One of the cool things with SQLite is they have something called row ID. So it automatically adds row ID for you, so you do not have to put the primary key in there. Again, also being SQLite is a little quirky because it's not an auto increment primary key. So if you delete a record that has a row ID, it will periodically reuse unused row IDs. So if you had a row ID, so you had a record with a row ID, you deleted that, but somewhere in your system you associated the row ID. If a new record gets created with that old row ID, since you deleted it, it will now be pointing to that new record. You get what I'm saying? Yeah. So that's one of the things you have to be careful about. When you're looking for row IDs, again, if you know anything about SQL, just to show you this, again, select all from thread. When I do this, you'll notice there's no row ID. So this is what the request is, this is what the response is, and this is what the timestamp is. To get the row ID itself, you actually have to call it. So row ID, I think it's query response from thread. So actually by calling the row ID, we'll give you that row ID. So it is there, just one of those quirky things to be thinking about whenever you're designing your system. Again, it goes back to that whole whiteboard. Doesn't matter, are you going to be, again, like you think about the vendor ID. If you make the vendor ID the row ID, you delete a vendor because you no longer need the vendor, and then think about that, you create a new vendor that now gets that ID that you were using before, everything can kind of go to hell. Joins, just so you know, SQLite does not support all joins, and there's something called foreign keys. We're not going to get into tonight. If you know what a foreign key is, SQLite doesn't support foreign keys for whatever reason. Yes?
Why do we create the table with the column name, which is row ID?
What's that?
You may create a table with the column name, which is row ID, the same column, the same name.
Well, it automatically creates a column called row ID. So it automatically does that. So if you want a primary key, you just simply have to add the primary key to it.
I'm just thinking like arbitrary column, like row ID, the same name. Is it going to override the system row ID, or is it going to do it?
Oh, this is why I love being a teacher. I don't know. Play with that. See, I would have never thought to do that. It should not work. I don't know.
Try to create the column. I don't know what the behavior is.
Create a table test, row ID, name. It did. Insert into test, row ID, name, values. So here we go, doing SQL here. Row ID of 55, and name of Bob. Select row ID, name from test. So oh, weird. So that's not a good thing. So well no, because this should be 1, right? It's the first record in the table. So row ID should be 1, and then this should be 55.
What if you just
Yeah.
ID is overrides?
Oh, just overwrite? Yeah, maybe just over.
Does it call it row ID
Yeah.
or calls it ID?
It's calling row ID. So I guess, yeah, so you're overwriting. So yeah.
It's one of those subtle interview
Yeah, I don't know. Oh, Lord, I've been doing this stuff too long. Yeah.
If we were thinking now production, like what database would you recommend?
Oh, in production, it depends on what you're doing. So that's the whole thing. Like once you go to production, again, you're talking about these database management systems. One is what is legacy? What the hell does what is your customer? What does your employer already have? And then what's really interesting, like you get into it, with things like, and don't quote me on it, it's like MySQL is faster, I think it's with inserts. So if you're adding data to the database, don't quote me. It's one or the other. MySQL is faster, I think, with inserting data into a database, and Postgres is faster at doing selects. Again, it may be the other way around.
It all depends on the engine.
It-
MySQL also have like different engines on it, so.
Yeah, so, but that's the kind of thing, like, that's where you sit down and you figure out exactly what you're doing and exactly what you care about and do a hell of a lot of research. And again, the whole whiteboard deal. Yep. Okay, let's see here. Water.
Oh, so does that auto increment then, if you just said insert into test? One of the ways to do it sometimes is to just put a null there, or instead of 55, just add it to your cache.
There are no dumb questions. There are off-topic questions. So this is. No. We will get into a SQL class, and I'll make sure I try to answer these questions in the SQL class. We're actually trying to get the AI component. We're setting up for the AI component, not trying to get into row IDs here. Okay. Just so you understand. Yeah, again, so for this class, like I say, we're just giving a basic overview of SQL. We will have a full SQL class in the future. When we start talking then about using Python, so again, we talk about Python. Python is the back-end programming language that we're actually going to be using to communicate with SQL, right? So you have Ollama. So Ollama is the LLM framework. Again, you can run it at the command line. SQL, you can interact with the command line. You use Python to actually be able to tie, superglue all of this stuff together. So with that, just kind of to give you a little bit of an overview. Again, overview here. So when we go into the examples, I will have created what's called a class for the databases. So basically, a class allows you to dump a whole bunch of stuff into one thing, make it a lot easier to look at. But basically, these are some of the functions that I've created for the different projects today. So for the create, so every time we're going to run one of our scripts, we're going to run this particular function. And what's cool here is you can do a create table if not exists, and then whatever the name is. So one of the great things about SQLite, especially when you're running this on a new computer, is it can automatically create the database for you, and it can automatically create the table for you if those don't exist, so you don't have to manually create that every time. When you're looking at this, the first thing you're going to do is you're going to connect to your database. So this is where you're going to say what database you're actually connecting to, and this is where you create what's called a connection. You then create this thing called the cursor. And so basically what the cursor is it's Python's version of the command line, so it can actually send commands to the SQL database. This is just how it works. We then, many times, will actually do a SQL statement. So here's a SQL statement here. But here, we can simply do execute. So create table, if it doesn't exist, picture, path, and description. So that is going to be the SQL statement that goes in. We then do connection.commit. So this is a weird thing with Python and SQL. If you do not run that function, it did not happen. Like it runs it, but it literally doesn't commit it, so it doesn't happen. So always make sure whenever you're modifying the database with Python, you run that commit function, and then you also have to do the close function. So this is going to open up a channel or whatever to the database. If you don't close it here, you might run into a problem where your computer is opening multiple connections to the exact same server, and at some point you might do your own denial of service attack against yourself if you don't close it. So it's one of those weird things, right? So that's how you can create. If we come here, again, this is an example from one of the labs we're going to be doing. So here's the function. So we're going to add, so the path is going to come into this function, the description is going to come into this function. We're going to connect to the database. We're going to create the cursor. Then what we're going to do here is for the SQL, so this is going to be the SQL statement, insert into picture, path, so that value is going to, or no, sorry. So this is going to be the column. So insert into picture, path column, description column. Then you're going to do values, and then you're going to do question mark, question mark. So here's the thing. You could actually drop these values directly into here, but there's a potential somebody could do what's called a SQL injection attack. So this is the actual SQL statement itself. So if somebody is able to add injections somehow into the system, they could try to compromise your system that way if you add the SQL values. So why we use question mark here is so when we go to execute, so cursor.execute like we had before, here's a SQL statement, and then the path value comes in and the description value comes in. By doing this, it compartmentalizes those values so that you can't do a SQL injection attack. If somebody tries to add injection code, I will always say it should fail the hell out instead of actually compromising your system. So that's why we do these, that's why we do it this particular way. One of the things to realize here, just when you're doing this is something called a tuple. So it's a data set. So a data set is a variable value that can hold multiple values. So you always have to have a comma here. Even if I just had path, even if I was just simply adding one value, you still have to put a comma after the path because it's a tuple, and so it's looking for that comma. One weird quirkiness there. Let's see here. The final one, just to be taken a look at with Python, so we do the connection. Here, we're basically going to be doing a search. So select all from picture where description is like. So we're going to use a wildcard. Basically, this is just going to try to search through our database and find something. We do like question mark, and then here we're going to do an F string. So you do F, then you do a single quotation mark around it, and then we do these parenthesis signs. So parentheses are for the actual wildcard, and then you put the query in between all of that, and that's what you send up to the thing. I do not have a tuple there. Anyways, so that's what's kind of going on there. For that, we do a fetch all. This is something called a fetch all since we're actually pulling values out of the database, and then we can actually return the results there. So this is kind of like how the Python looks. Again, we'll get into it more. Is there any kind of questions with how that happens?
Am I reading it correctly, or is there like a typo after execute open parenthesis SQL and then the parenthesis should not be go right?
I'm sorry, where are we looking at?
Result equals cursor dot execute open parenthesis SQL, then close it instead of remaining open to let the because then after the comma
Oh.
seems to be like a different. Is that how it is?
With this one right here?
Yeah.
Yes, I do believe, actually, as you say that. So it should be X, yeah. There should be, I don't know how that slipped through. That should be multiple parentheses. Yeah. I will do a note right there, fix that. Okay, there we go. Cool. Now we'll start getting into the AI stuff. So again, no questions up until this point. Got to run through. Everybody kind of got the idea? Okay, so we did Ollama before. I just want to do a brief overview of Ollama again so everybody is on board. So what Ollama is it's a local LLM framework. So you can download Ollama. You go to ollama.com, you download Ollama, and then you're able to interact with Ollama, be able to ask it questions, so on and so forth. So basically you can use Python, and we have this basic Ollama script here. So if we take a look at this, this is the Ollama script. So again, from Ollama, so you go to ollama.com, you install Ollama. Then what you're going to do is you're going to pull the model. So Pi3, we're going to use Pi3, PHI3 for a lot of these examples. Pi3 is very small, it's very lightweight. It is quirky as a mofo though, so just kind of keep that in mind. A lot of times you're going to look at the response and you don't know if you screwed up your code or if Pi is just really screwed up, so do be careful with that. So anyways, we have the things here. So again, so in order to pull a model, you do Ollama pull, what the model name is, and then you do have to run the model. So Ollama run model, and you would do that all from the command line. So we talk about pull and that. So if we do exit, clear. So we do Ollama pull, let's say Pi3.
Would different models be more, well, I guess, architected to specific use cases, I guess?
Yeah. So there's, we're going to be using, this is the Lava model. So we're going to be using one for image, understanding images with one of the examples today. So yeah, different models can be designed for different things.
For images, one might be better for like hard math. One
Yeah.
might be better for science, stuff like that.
Yeah. So that's the thing. Like if you go to Ollama.com, like it's no joke when I say there's like 1,000 models now. Basically, I mean these are all the models you can pull.
Yeah, I started scanning and I haven't finished scanning. So.
Yeah. So basically all you do is you would pull the model in order to install it, and then you can run it. So if you do Ollama run pi3, now you can simply say like hello. And again, this is where you actually, so you have a Ollama shell, and so now you can talk directly to Ollama. How big is the moon? Right? And so it can do all of that kind of stuff. Again, obviously, so like I say, you've seen the SQLite shell, you've seen the Ollama shell. This is cool, but it's actually not very useful for us, and that's why we use the code. So this is the code. This is basically a pretty simple example, right? So this is where we're going to be bringing in the functions for Ollama. So from Ollama, import chat, and from Ollama, import chat response. This is kind of just the copy paste from them. I don't know why they don't say comma, whatever, but they don't. Here's the function here. So this is basically all you need for Ollama. This is where I say AI is hard, APIs are not, right? The engineers for OpenAI are fucking brilliant. I will never be able to compete with them as far as brains are concerned. The cool part is I don't need to be that smart. I just need to be able to write 6 lines of code. If I can copy and paste 6 lines of code, I get all of the value, right? So anyways, this is a function. So response colon, so this is going to create a variable named response, and the value and the data type that's going to come back is an object. Chat response equals, we're going to say model is pi3, and then just leave the role as user, content is query. So this is where we send that. This is where we say hello, this is where we say how big is the moon, how fast does a squirrel fly, that type of thing. Then the response that's going to come back, it's going to come back as an object. So we don't want the whole object. We don't want just the response object. We want the actual content itself. So response.message.content, this is going to be the message that we actually care about. So we have this little while true loop here. While true just keeps going through. It's simply going to ask, how can I help you? You're going to plug in whatever your query is. It's going to send that query to the AI function. You're going to get the response back. You're going to print query. You're going to print the response. So this is our first little AI program. This is the basic thing, like I showed you folks how to do before. And so now from my program, I can now say hello. I hit enter, hello, how can I help you today? So this is out now actually all being done through Python. So this is the basic concept of Ollama. Everybody kind of got that? Okay, so we got the idea of SQLite, and the idea of Ollama. Okay, cool. So then, the first thing we're going to do is we're going to go into an app with logging. So what this is going to do is it's going to add requests into a database. Or it's going to add the request and the response into a database. What is this one called? Logging. So basically what's going to happen here, so I'm going to hit go, say how can I help you, and then say what color is a tree? And it's going to say answer in under 10 words, what color is a tree? Not specifically one, but typically green due to chlorophyll. So one of the important things to be thinking about when you start building your systems for your customers or for your boss is to think about the #1 threat to your company. Right? Whenever we think about the #1 threats to our company, we think about North Koreans, we think about the Chinese, we think about the NSA, we think about all these, super secret spies that are going to like infiltrate our systems. The #1 danger to all of our institutions are the employees. Employees do shockingly stupid things, and they do it on the company systems. So one of the things that you should be thinking about is when you create an AI system, simply by logging what the hell your employees are actually asking, you might be able to figure out there's an issue before you guys actually get sued for that particular issue, right? And so one of the things with this is it's just a very basic system where once somebody puts in the request and once they get the response, that will simply go into a database. Now again, remember, think about this. All the database is a record store. So all we're doing here is we're going to the LLM, we're saving the stuff into the record store. That's all this system does. But once we save it into a record store, that record store can be connected to by any system that we create. We can create a web app system to create a dashboard. We can create a script to look for bad words or whatever else. We can do a lot of things once that data is actually stored into that database. If we go and we take a look at our SQLite table, what is this one? Is it by? There we go. If we go into our database, SQLite AI class, right? Tables. So we have the thread. So we do select all from thread. We can now come down here and we can see that we actually have a timestamp, answer in under 10 words, what is the color of a tree, not specifically one, but so on and so forth. So basically, whenever I'm going to use a system, that information is going to be stored in the database, so we can take a look at that later. When we go and take a look at the code itself, it's pretty simple. So up here, again, Ollama, chat response like we had before, and then we're going to import the SQLite module. So SQLite 3 is basically how you interact with it. You do not have to install this module for it to work. It's just going to be there. We're going to put an injection in here. I was deciding for this class whether or not to put injections, especially with Pi 3. Pi 3 gets a little chatty. You know how you deal with people sometimes that just, you ask hello, and then they tell you your entire life story. Sometimes you'll ask Pi 3 hello, and it will tell you its life story. So by putting this little injection in there, it's just like, just keep it down to 10 words. Don't be too long. So whether or not you want to do that, it's kind of up to you. Let me close this for a second and close this. Basically, we're going to come down here. So this is what we call a class. This is the class that I talked about. So when we create a class, this allows us essentially to put a lot of these different functions into one grouping, and that makes the code easier to read. So I can now simply collapse my entire database class, and it's kind of gone away, and I don't have to look through it as I'm going through my code. So we're going to see I have a class for database that's going to contain all my database functions. I'm going to have a function for AI. That's what's going to send the query to the AI. And then what you'll notice here is this, the first thing that I do is I'm going to call the database class the create function. So class DB and then function create. And so the first thing for all of my scripts is I'm going to run this create function that I showed you before, just to verify that the database actually exists. So here, class AI, as we've had before. So with this, create table if it doesn't exist. Thread, I want the query, I want the response, and then this is how I can put a timestamp in. So created at column with this timestamp data type, so it puts a timestamp in there for me, right? So that's the first thing that we are going to run. Then we're going to come down here, and basically we have this while true loop. So like I showed you before, so query equals, here's the input function, how can I help you? We want to keep it down to 10 words. So this is where we're going to concatenate. We're going to put two strings together. We use something called an F string. So the injection, 10 words or less, along with the query. That is now going to be query. We're going to then send query up to the AI function. The AI function is going to basically be the AI function that I showed you before. So the model is going to be Pi 3, and we're going to send the query. So whatever that is, that's the value that's going to come back. From there, we're simply going to do the DB insert. So basically, for the database class, we're going to do the insert function. We're going to send the query, and we are going to send the response. If we come up here to insert, we have this function, basically pretty simple. Query and response come in. We're going to connect to the database. We create the cursor, insert into thread, query response, values, question mark and question mark. Down here, we're going to say execute SQL, comma, query and response. So those values are going to go in. We are going to commit, because if we do not commit, it doesn't actually happen. And then we're going to close the database. We're simply going to print out the value for query. We're going to print out the value for response. We're going to print out a line just for user interface, and that's how we're going to go through. Every time we make a query, it's going to go to AI, we're going to get the response, we're going to take that query, we're going to take the response, we're going to send that, we're going to insert that into the database, and then we're just going to keep going along. That's one of the big things to understand. Again, understand with technology, one of the reasons I do these classes this way, I build everything up, is it's important to understand everything in technology is really simple. Like again, it's like HTML. HTML is simple, CSS is simple, SQL is simple, Python is simple, LLMs are simple. You know, adding 50 of these things together is what makes it all complicated. And so that's why you kind of build up slowly in these systems. Okay, so this is the first thing with logging. Any questions with that?
In order to work, you need to use Python 3.8.
What's that?
In order to Ollama work, you need to use Python 3.8.
Oh,
case.
okay.
So there is no mention here.
Oh, is because we're up to like 3.13. Okay, so, okay, I may have to put that in there. So yeah, you probably do need 3.8. So yeah, with Python, again, this isn't truly an introduction to Python class, but anyways, yeah, so with Python, Python is an interpreted programming language. So we have text, this gets run through an interpreter. The interpreter itself is a program, so they get updated just like everything else. Again, so the normal Python interpreter, what do I have on here? I have Python 3.13.1. So this is either the latest or close to the latest. So 0.8 came out a while ago. So, but yeah, you do need at least, I guess, 0.8 to run it. Yeah. Any other questions?
I think you said before, but you're separated between the injection and query is 2 dashes. Could that be anything, or do most models standardize on the?
It can be whatever works for you. Remember, this is where we go from science to stupidity. So all the rest of this is technology. This is stupidity. This is like you just feed it to the LLM, and you see what the hell gives you your response. So that's where you'll notice. So like with this, it's simply keep it to under 10 words, hyphen, hyphen. This is all we do, and this seems to work fine. Whenever I run this works fine. What you'll notice is, as we start doing more complicated contexts, that is where you'll notice this F string starts getting far more complicated as I try to, because again, the important thing to understand is LLM is not, and when I say this, I'm not being snarky, LLMs are really not intelligence. They're this weird correlation, hyper complicated, resource intensive correlation system. And so basically what you're trying to do is you're trying to get your tokens to properly correlate with its tokens to give you the response that you're looking for. And so that's where they talk about being a prompt engineer, is literally understanding what to ask this thing. So that's it. Like it's an interesting thing. Like I just found out, I was talking with some people, and apparently XML. So if you're trying to get out what's called structured data, so there's something called JSON, we'll talk about in a class coming up. There's different ways of pulling out data and basically typing what the data is. So what's interesting is a lot of these LLMs are actually much better at putting out structured data as XML, this thing called extensible markup language, versus JSON. And the reason simply is when you go on the internet, almost everything has an RSS feed. Therefore, there are far more examples of XML online than there are JSON. So it just happens to be it is better at pumping out XML than it is pumping out JSON. So it's that kind of weird, like, and I was like, until somebody explained that to me, I was like, what? And I'm like, oh, okay, that makes sense, right? Anyways, okay, got that basic idea. So the next example then, we're going to be doing SQL report. And so the idea then here, again, as we build up, so anybody that's new to the class, we're basically trying to build up on concepts here, is what we're going to do is we're going to create a system where then we can output the queries and responses to something, let's say, in a web page. So I can say, how fast does a squirrel fly? Squirrels don't fly, they jump, blase, blase. The important thing is this went out into here, reveal in Finder. So it created this HTML document, and so with this HTML document, what is now happening is it is going to this database. It's pulling the information out of the database, and right now all it's doing is it's simply writing that to an HTML file. So this is really ugly because we're not doing any formatting yet. These are simply pulling out the record values. So here we can see, hello, hello, how can I assist you? And here's a timestamp. What is a cat? And here's the information for a cat. And the idea here is we are now starting to create a system that somebody like a manager could actually take a look at. Like, hey, I just want to have an idea of what the hell my employees are asking the system in a day. And so even something as simple as this, I mean, it's ugly as hell, but they could actually scroll through this and be like, okay, this is what my users are actually asking for. And this is in HTML. So it's not SQL, it's not Python, it's not something else. This is something, a web page. You could literally output this to an Apache web server or an Nginx web server, and they could pull this up as one of their dashboards to get an idea of what's going on here. If we take a look at the code, come up here, and again, we see that the class, it starts getting a little bit more complicated. Got report. This is also too, we're talking about things like functions. Again, if you're new to programming, basically functions allow you to create reusable, useful bits of code, so then you can simply call those reusable bits instead of having to rewrite them every single time. So we take a look at this. Again, same as before, the Ollama stuff, the SQLite stuff, and the injection stuff. We have a class of DB. We have a function of report. This is actually going to create the report for us. And we have the AI function. The important thing, we're going to do DB create. So this is going to create that table. If it does not exist, make sure that's there. What's going to happen here is, again, we have the input function again. We have the injection as we had before. Response equals, we're going to do the AI query. So we have the AI function. We're going to send the query. We're then going to do db.insert, the query and response, as we did before. So that's going to insert it into the database. The new thing that we're going to do is we're going to call this report function, right? So basically, what's going to happen with the insert, we go to db here, we do the insert. So the query response, we're going to insert into thread, the query, the response, and what those values are. We're then going to come down here to the report function. So in the report function, we're actually going to call a select function within the database. So response is going to equal db.select. This is where we come and we actually grab all the values out of the database. So we're going to do the connection, we do the cursor, then we're going to say select all from thread, then we're going to execute that SQL statement. Result equals cursor.fetch all. So this is going to fetch all of the records. So you can do fetch all or you can do fetch one. There's some different things you can do here. It's going to fetch all of those records. We're going to close the connection and then we're going to return that result. So this is going to come back as a set of values. So what we're going to do here then is we're going to say with open. So we're going to open a file. We're going to do W for either create or overwrite. So ai-report.html. So we're going to either create this file or we're going to overwrite it as file. And then when we get these the data set back, it's going to be basically like a list. So when you deal with other programming languages, it's arrays. Everything's an array. When you deal with Python, they separate all this stuff out into different things. Basically, they're sets of data. So what's going to happen is when you bring this back, the response back, it's going to be a set of data. So you're going to have the response, and then basically you do what's called a 4x loop to step through all the values in response. So for line in response, we're simply going to write everything that's in that line within a p tag. So basically you're going to have a line, and so that's why it has all that stuff to it. It has the parentheses and all that garbage information, because that entire line is simply going to be written to the HTML file. And that is what you get when you're looking at this. Let's see here. And that's basically, again, we print out the query and the response onto the screen so you know what's going on. Do you basically understand what's going on here? Oh, I worry. I worry if people do. Okay. But this is the basic idea, right? As we start building this up, right? So, okay, so we've got the LLM. We create the LLM, so that allows us to interact. Then we create the database. Then we start dumping data into the database. Now the data's in the database, we can start pulling data out of the database. And we can start building this up into something that's kind of interesting. The next thing is basically all we're going to do, just so you understand with HTML formatting, is we're going to create a cleaned up version of what we just did. The only difference is going to be the report function here. And this is where I talk about with technology, everything is simple. Everything in technology you can learn in a day or 5. You just build up 50 of these things. So with this, what we're going to be doing is with Python, we are going to be creating a file that looks a little bit cleaner, right? So I come here and I can say, what color is a frog? Generally green or brown, right? So I can come to the HTML that should have been created right now, reveal in Finder. And with this, it looks a little bit better. Still kind of ugly, but again, it's a class. So basically what we're looking at now is this is a table in HTML. So where before you just had that ugly data set that got printed out, now you have a table. We open the table, we close the table. We have a row, this was what the query was, here was the response, here is the timestamp. Query, response, timestamp, so on and so forth. So basically the extra credit here is where you start adding CSS to this to make this look something pretty enough that an executive would want to look at. But this is just kind of giving you the idea of how you can clean up this information. If we take a look at this, again, the only difference with this particular example is this function itself. Everything is the same. Everything else is the same. One of the big things to be thinking about, and this is where we go back to the whiteboard, where whiteboards and programming is very important, is to think about how you're going to be automatically writing this HTML document, because you have to logically think about how it works to make sure it works properly. So the first thing that we need to think about is we're going to have a table. We're going to have a table. So we need to open, so file.write, we need to open the table, and at some point we need to close the table. So we're going to open the table and close the table. But then we need to add lines to the table. So basically we need to open and close the table outside of our loop. Because if we open and close the table inside of our loop, we're just going to end up with 500 tables. So we need to open the table, add rows, and then close the table. So for line in response like we did before. And so we're getting back basically these data sets. So request equals line 0, so at index 0, that's going to be the original query. One of the things that we want to do is we want to clean that up, right? So we're going to say, we're going to replace whatever the injection is plus a space hyphen hyphen, right? So that was answer in under 10 words. We want to get rid of that so it's cleaner. Can somebody hit the, or be careful of the thing. There we go. So anyways, so basically we're going to replace that. So we're going to get rid of that, right? So you'll notice here, again, hello, right? We don't have any of that injection there like we had before, right? So we're going to replace that with nothing at all, right? So that's going to be the request. Then we're going to do file.write f string, so it's going to be this long thing. tr is table row, so for each row in the table. Then td is for each whatever that is, little bubble in the table. So we're going to, what's that?
Table data?
Table data, yeah, it's table data, but whatever that little block is.
The cell?
The cell, there we go, cell. So in each individual cell, so TD is cell, basically. So it's going to TD, and so what the new request is. So whatever the request was, minus the injection, it's going to dump that in there. We're going to close TD. We're going to open a new cell, then we're going to do line 1. So we're going to do line. So line 0 was the query. We cleaned up the query, that's request. Line 1 is then going to be whatever the response was. We're going to close the TD. We're going to open the TD. Line 2 is then going to be the timestamp. We're going to come here. We're then going to close the table row. So basically, it's going to go through for every single record in the database. It's now going to create a table row with all these different cells. Once it finishes, it will then close out the table, and that is what gives us this thing. Had the idea on there? Yeah. And so this is where, again, as I say, for your extra credit, you can start adding the CSS and start really trying to modify that and clean it up and make it look pretty. And this is also why a lot of people get snarky about designers. And I want you to understand that whenever you're working on a team. Like, whatever your job is, you think that's the most important thing. Like, we do the important work, and they just get paid off of our labors. The important thing to understand is this is what people like me put out. I would be more than happy to give this to a CEO and not think twice about it. Let me tell you, that's why designers get paid big bucks too, because they turn this into something pretty that a user actually wants to use. What is funny, especially having done technology for so long, is you can see the companies that pay designers and the companies that don't. Like you will get to like a dashboard, and some dashboards are intuitive and they have, you're like, wow, this is easy to use. And then you'll go to use an alternative product that technically does the exact same thing, and the dashboard is confusing as hell, and it's really hard to read the font, and yeah, so that's what designers get paid for. Okay, so that is pumping stuff out into an HTML document so that it looks a little bit pretty. Everybody has the idea there? Okay. So now we're going to go to apps with preferences. So this is where we start talking about things like the context windows and how we can start playing around and having some fun. So when I run this, just to give you an idea of what's going on here. Can everybody see this actually? Everybody? Sort of? Okay. So how can I help you? And now you'll see I have some commands. Please, list, and delete. So what I can do here is I can simply say hello. I may use GPT OSS on this one. Dum-da-dum. Okay, yeah, I use GPT OSS so that it actually reads the damn rules. Anyways, so I say hello, and you'll notice, hello dude, how are you? I'm excited just like a playful fish in the sea, right? Because I want to give my LLM a bit of personality. And then you're sitting here and you're looking at this like, what the hell is going on? So what I can do is I can use a command called list. And what this does is it shows me all of the rules I now have in the system, right? Please always say dude. Please always capitalize all words. Please always be happy. Please answer in fewer than 20 words. Please always relate, answer to fish. And this is going to be one of those things too, when we talk about what LLM to use, is when you use Pi 3, you really don't know if you suck at Python coding or if Pi 3 really sucks, because you feed it these rules and it gives you something that's sort of like the rules, maybe. So again, GPT OSS actually follows these rules. So what's happening here is for the injection. So the injection that we had before, I just simply said answer in under 10 words. Now what we're doing is we're going to the database, we're selecting all of the rules, we are turning that into part of the injection, so that's the prompt injection, and then we're adding that, right? So if I want to delete, let's say I don't want one of these things. I don't always want to say dude, right? So what I can do is I can say delete, and I can say 1, right? So again, something you have to think about with user interfaces is how are you going to define things? So we have these numbers, so I do delete 1, and now we can see 1 is now gone. So what I can then say is I can do is please always say man. And now we can see down here, please always say man. It's now no longer always going to say dude, it's always going to say man. And I can say hello now. Wait a minute.
So the rules are going into the database?
Yep. So, hello man, gleeful fish swim by, wish you a fishy day.
I got a question.
Yep.
It's about a couple of technical terms. Context window and tokens, I've heard you mention them a couple of times, and I've heard other people mention them. Tokens are the individual words within the greater string, correct?
No, okay, so tokens get stupid. So tokens are, and this is where I say this is not intelligence. It's really important to understand this. So what happens is whenever you're training the model and when you're putting information into the model, making the query, what happens is tokens are words, parts of words, or symbols. They get turned into a numeric signifier. It then figures out the statistical relationship amongst those tokens. And then it basically what it does is it then compiles a set of tokens and puts those in an order. And then it's basically like flipping up cards to then what the words are. So that's why I say with the intelligence, it's a very big math equation. So we talk about tokens, that's what a token is. So it's a word, part of a word, or a symbol. When we talk about the context window, what the context window is when we send that entire query to the LLM, that is the context window. So the context window is going to be the query itself. It's going to be something like an injection. When we start using something called RAG, so that'll be months from now once we get to RAG. So something called RAG is retrieval augmented generation. This is where you have a database system. You use something called vector databases with things called embeddings. Basically, it allows you to store a tremendous amount of information. And then when you make a query, out of that entire database, it finds a specific information that might relate to your query. It will then take that information and then add it to your query. So if you say how, let's say your company created a new programming language, and so you create a lot of documentation for that new programming language, you would then create a database, a RAG database of all the documentation. When you ask, how do I do X in this thing, it would then pull out all of the things that might answer your question. Your query plus all of that, plus anything else, will then go to the LLM for it to give you the answer. And so that's the context window. Yeah. So that's the thing. It's like we talk about the prompt, and that's why prompt engineering is not context engineering. Prompt engineering is how you ask the question appropriately. Context is how you pull in all of these information from different sources and then provide that to the LLM in a way that hopefully it's going to give you a reasonable answer. Yeah.
How big is it?
So in the previous example, you then said, okay, don't do number one, and you're going to talk about fish, and you're talking about
Yeah.
salmon. But is the LLM handling that in the context window, or did you go in and fix your rules?
I fixed the rule. We'll talk about that. I'm just giving you the demonstration, so you, yeah. I'll show you that in a second. Yep.
How big is the contact window for the Ollama that you're using?
I don't know how big that can get. That's one of the big problems you run into now, and that's where you have to be careful with context windows. So it sounds weird to say it was nice 3 years ago when I started teaching the class with OpenAI, because the context window was only about 4,000 tokens. So 1,000 tokens is approximately 750 words. So worst case scenario, you can put in 3,000 words. The issue now is if you use OpenAI, you can have a 1,000,000 token context window. And so the issue that you then run into is, again, it's kind of it's like once you can swipe your boss's credit card, do you take 3 extra minutes to clean up your query, or just charge your boss $1 every time you run the query, right? And so that's the thing is that with context window, you just have to look at the particular data, the LLM system that you're using and see what it is. That's the other thing too, is the thing about these context windows is the smaller the context you send, the faster the response you're gonna get. And so that's another thing to be thinking about with cleaning it up, so yeah. Okay, so when we take a look at this, again, we got our database class like we did before. We have the AI, we have the create. Okay, so basically what we're gonna do is we're gonna come down here. We're gonna do a while true loop as we've done before. We now have an if, elif, else statement, right? And so that's all we're doing here. So basically it's gonna say, if please is in query. Now with this, it's very ugly, it's very simple. Please could be at the end, please could be at the beginning. You could ask something and it could think please. Again, this is just a simple concept here. But basically it's gonna say, if please is in the query, what we're gonna do is we're gonna go to db.rule_new, what the query is, and then we're gonna do rules equals db.rule_list, and we're gonna print out the rules. So we're gonna go up to the db class with the new, rule new. Right, so we're gonna go here, and so basically if all we do is if we say please, we're going to do insert into rule values, and then we're gonna insert what that rule is, and so that's gonna go, right? Then we're gonna see here, after we do that, again, as a user interface thing, we wanna see what our rules actually look like. So we're gonna say rules equals db.rule_list. So this is where we come up to the list function, and it's going to say SQL, and this is where we're going to select row ID. Again, if we're going to be interacting with records in the database, we need a value to interact with that is not going to get confused with something else, right? Because remember, whenever we do something like delete or update, it will do that to any record where that matches. So if you said delete, let's say please or something, it would literally delete every record that said please in it. So you need something like the row ID. And again, that's where I talk about with row IDs and auto-incrementing primary keys. In this kind of system, row ID is fine because of what we're doing. Also think about this. If this was something a more complicated system, what if a row ID got reused and then all of a sudden you start deleting things that you don't want to delete? You have to be careful there. Anyways, so basically we're just going to select row ID. Cursor, we're going to execute. We're going to fetch all. And then what we're going to do is we're going to come down here and we're going to clean up those results to make them look prettier. So rules, so this is going to be a string for value in result, that result that came back. Rules plus equals. So what this does is it adds the new value and sets it equal to the results, to the variable. So we're going to do an F string. So we're going to say value 0. So this will be the row ID. So I say row ID space hyphen value 1, and that's going to be the rule. So that's why it's going to say 1 hyphen rule, 2 hyphen rule, 3 hyphen rule, and then we're simply going to return that back, and that's what's going to get printed on the screen. All right. So that's for please. List. All list is going to do is it's going to go to that rule list function and going to do exactly what I just showed you. It'll print that out. Then what we're going to do is we're going to go to delete. And this is where you have to be careful. You have to be careful in a number of counts. One, you have to be careful you don't delete the wrong thing. And two, you also have to clean up the value so that it actually matches something. So remember, white space 1 is not 1. 1 white space is not 1. 1 is 1. So that's one of the things you have to think about whenever you're dealing with like Python databases. So else, if delete in query. So what we're going to do is we're going to take the query that comes in, and what we're going to do here is we're going to split it at the space. So we're going to say, so when I plug in, I say delete, and I do a space 1, delete space 5, right? So I'm going to split at that space. So it's going to turn it into a list. So delete will be at index 0 at this point, and then the rule number will be at index 1, right, when we do that split. Then we're going to say, so for rule 1, so rule 1 is going to be the actual number that we care about. We're going to use what's called the strip method, and the strip method is going to strip out the white space on either side. So we just have the number, right? Then all we do is db.ruleDelete. We're going to send rule 1, right? So we send that up to delete. And basically all this is a SQL is delete from rule where row ID equals, and whatever that rule number is, we're going to commit and we're going to close. Right? Then after that, we're going to print out the rule list like we did before. If you don't have please or list or delete, then we actually want to run the query. So rules, it's going to tell us what the rules are. We're then going to say follow these rules. So this is where the prompt starts to get a little bit more difficult. And again, this is where it becomes more art than it does science. It really does. So, okay, so /n is for next line. So we're going to say follow these rules. And then next line, what the rules are. Next line, to answer this query. Next line, query. So I basically tried to format this. I think this is more complicated than I need for GPT OSS. I was trying to make this work on Pi 3, and we now use GPT OSS because it was a damn disaster. So anyways, but this is where we start getting into that whole prompt and that whole context window engineering of trying to make it so that the damn thing responds decently. So response equals AI query, and then we're going to print out the response. So we go here. Oh, see you, man. And that's where we say now, goodbye. Again, it's going to go, it's going to grab that rule list, and that's going to give us the response in a second or two. There we go. Goodbye, man. Have a fishy day. There we go. And this is how you can use the database to start adding those kind of rules. And the cool thing here is, again, you can now create 500 rules. Or the cool thing is, again, if you have user accounts, think about this. If I was logged in under my user ID in the database, it could save both user ID and my rule. When I then make a query, it would then go to the rules database and say, get the rules for this particular user ID. And again, that's where you can start building this out into something far more complicated. Cool, cool, cool. Preferences. Okay, any questions then? Any questions? Yep.
The code in the delete statement, can you go back into it?
Go back into the if statement.
If delete, you see?
Yep.
So basically, it's better to do the query strip first, and then do the split and take the rule -1. So it will get like the last character. Because like if you do this split first, it's going to create an array with a bunch of like empty like elements inside. If you have like more than one space between the delete and the 1.
Oh, this.
So basically, the strip command can eliminate all the white spaces before and after.
Yeah, you're probably correct. I would have to take a look at actually making sure. Just remember, when I'm writing this code for you folks, I'm trying to make it like as simple as possible. So one of the things understand with these classes is there's a way to put stuff into production and there's a way to try to teach things. And so, again, I'm not sure that strip would work the way you're saying it would. Maybe it would. This is just kind of a simple way to show it. Yeah. So again, that's one thing in production. Because if you did the strip beforehand, you'd strip. But if I did space, space. But yeah, if I did space, space, then it would do different lists. Yeah, I'd have to think about that a bit. Yeah. Anyways, you're probably correct. You're probably correct. Okay, so let's look at caching. So this is going to be a big thing for you folks to be thinking about. Memory cache. Is, as you've been seeing, every time I make a request here, especially when you use GPT OSS, it takes a few seconds to run, right? It takes about 10 seconds to run. Imagine if you have 100 users all hammering the hell out of your system, that's going to require a lot of resources. That might require a $10,000 or $20,000 server, or if you're going up to OpenAI, every time a user makes a request, then it's going to be charging you for that number of tokens. One of the things you need to be thinking about, again, we go back to the whiteboard. This is what's most valuable in our lives, is thinking about how we can design our architecture in such a way that we create a system that uses the fewest resources possible, right? So one of the big things in the technology world is the concept of caching. We cache everything that we can, right? And the idea is whenever we make a request to a different system, when we get the response back, we save that response at least for a certain amount of time. Like there's DNS caching, which is either a great thing or a complete disaster when you have to try to do troubleshooting, right? But that's the thing. The idea is you save it so you're not always making requests out to the other system. And so one of the things to consider here is, especially with LLMs, is that people are going to ask a lot of the exact same question. So if they're asking a lot of the same question, why hit the LLM all the time? If they're asking the same question, just hit the database. It's not going to require many resources, it's going to be cheaper, the whole 9 yards. And so that's basically the caching that system we have here. So when I run this, I'm going to run this, how can I help? And I'm going to say, I don't know, how big is a potato? I don't know, that's a stupid question, right? So you're going to see none, so it's not in the database. And we're going to do a little dance, because it's going to take a while. There we go. How big is a potato? And so now it gives me this whole information of how big a potato is. Now I can say, how big is a potato? And it's that quick, right? Because the first time it hit the LLM, it actually has to get processed, go through all the resources. The second time it hits the database, and it's as fast as the database is. The database is always going to be faster than an LLM. So if we go and we take a look at the code here, shrink all this stuff down. So again, we're going to create our database as we did before. Okay, so what we're going to do here is we're going to say query equals input, how can I help, as we did before. Then the first thing we're going to do is we're going to say find equals db.findQuery. So we're going to create a find function under the database class. We're going to send the query, and basically what we're looking for is we're going to be looking for if that that exists. So what we're going to say here is we're going to say, we're going to select query response from cache where query is like in question mark. And so this is where we can fudge it a little bit. So if our query is exceedingly similar to another query, basically it's just using wildcards. I'm sorry. Never mind. That's a weird query that I put in there. I should have done that differently. Anyways, just go with me for a second. So basically, we're going to put the query in. So I did a like here, but then did not do what I was supposed to do with a like here. So anyways, that's weird. Anyways, just this works. This functions. So basically, what it's going to look for is anything that matches that particular query. The result equals result.fetch1. So before we did fetch all, so fetch all fetches all records. For this, we're just looking for one record. If one record matches, we're going to grab that, and we're going to send that back as the result. So what we're going to say here is we're going to print whatever comes back with find. So you notice the first time we ran, nothing came back, so it said none. right? If something comes back, then it'll print out what came back. So if find, so basically what's going to happen is if a value comes back for find, we're going to print out find 0. So that will be the query, and find 1, that will be the response. And so basically that's just what comes back directly from the database. Else, so if nothing comes back from the database, response equals, we're going to go up to the AI function, we're going to send the query. Then when we get the response back, we're going to go new, so we're going to add, we're going to insert to the database or to the table, query and response, and then we print query and response here. So basically what happens, if we haven't answered the question before, it comes down here to the else statement, it adds everything, it prints everything out and adds everything to the database, and then if we ask the same thing in the future, it will just simply go to the database and print out. Does that kind of make sense there? Yep. And yes, this is the problem when your assistant is a Chihuahua. Chihuahuas do not catch when you create problems. So again, right. This is something that works. It works. It's just not how it's supposed to look. This is supposed to be a bit of a different query statement here. I was thinking something and then did something else. So anyways, it functions. So,
I have a question.
Yep.
Does it mean that the question, how can I help, has to match exactly the previous one? Because one of the advantages of LLMs is that you can ask, how big are the potatoes?
Yeah.
And you still get that similar answer, but in this case, if it doesn't match, or...
So again, so this is giving the concept of what is going on. So basically, if I did that weird F string in here, F, so if I ran this, right, this should work. So if I run this, and I simply say potato now, potato, it will look, if there's any responses that have a potato in it, or any requests that have a potato in it, and so it gives me that. So again, I think that's what I was thinking when I wrote the code. I don't know. Anyways, so that gives you a little bit more of you don't have to be perfect, a perfect match. So in Python, there are modules called diff modules. And so all the module does is it determines how close one string is to another, and then it gives you a numeric value on that. So what you could do is you could try to do a diff and basically go through, and if anything is 99.5% similar to another request, give that same response back. Again, that's where we take a very simple concept and you start building this into 1,000 lines of code. And that's why I try to keep all of this simple. So these are very simple concepts. Literally any of this that you would put in production is going to be 1,000 lines of code. So imagine you go through and you have to clean things up and you add a whole bunch of different statements and that kind of stuff.
I would
Yep.
go with Elasticsearch or something like that.
What's that?
Elasticsearch in this case.
Elastic?
Elasticsearch, yeah. So basically just put an Elasticsearch in the statement and then you can do similarities.
No.
Whereas
Fair enough. Yep. Okay, so we got caching done. Okay, so now we're going to give memory. Now we're going to give this thing memory. Got a few more to go. And so memory, this is what we were talking about before. So one of the big things when we talk about AI, we start dealing with LLMs. Again, in the first class when I talked about Ollama, he was here for it, and everybody's like, oh, well, it remembers. And I'm like, no, we didn't build that system. And then like 2 minutes later, well, it knows that. It's like, no, it doesn't know anything because we didn't build that system. And so one of the things we did before in the Ollama class is we actually built a memory using a text file, something called a CSV file. CSV files work, they're ugly, less security than SQLite has, and there's a whole bunch of problems with it. So one of the cool things you can do is with the database system is you can actually create a memory. So if we go and we take a look at memory, basically, what we're talking about with memory is that we can ask a question and then it remembers what's happened previously. So I can say, when was Reagan elected? So this is just printing out the previous things in the memory. It's now thinking about when Reagan was elected. Taking a second. When was Reagan elected? 1980 to 1984. Now, one of the things is when I'm dealing with a system, I don't want to keep having to be specific. So I can say, how old was he? Now notice I'm not saying Reagan, I'm not saying 1980, I'm not saying any of this information that's come out before. I'm simply saying he. I can now plug that in, and hopefully if the memory works properly. You'll notice all this is the previous memory, so sometimes this can be squirrely. He was 52 years old. Who was he married to? Okay, again, memory is not quite perfect here, so I asked about Carter before, so I think it's giving me Carter's information. Let's see, who was Reagan married to? Nancy Reagan. Let's see, how old was she when she got married? Uh, 45? I have no idea. Maybe, maybe not. Anyways, so basically what this is doing is it's creating a memory system for this so that we can then continue asking questions in a very natural way instead of having to be exceedingly specific all the time. One of the things I do want you to see with this, again, this is where we talk about, again, the systems that we create and how things go from 5 lines of code to 5,000 lines of code, is you can see it's getting confused. So it has a very simple memory routine here. It started to get confused between questions that I asked before and current questions. And so that's where you decide how you're going to build this thing. Will it only be a session memory? So like what I have here, just to be very simple, is this is only remembering the last 10 records. So the last 10 questions that I asked, it only remembers 10. So what you could do is you could have a session memory. So it only remembers things that I asked within this session. You could then expand and you could say, let's say, remember for a day. And then that, if you have a timestamp, it would then pull everything for the past day into memory. But then also if you do that, you're also creating a massive context window. And this is where we start talking about architecture and engineering. It's like if it has a day's worth of memory, it's going to be more accurate. It might also take you 5 minutes to get a response. And that's kind of what you're thinking about. It's like, okay, well then you buy a $20,000 server. It's like, well, if your boss gives you the credit card, right? So that's the thing, like, will the boss give you the credit card for a $20,000 server? That's where you gotta figure things out. Question? Yeah.
Memory and context are unrelated.
So yeah, so the memory. So this, what's getting printed out here, this is the memory that's in the database. So this is getting put into the context window along with your query. So when I ask, how old was she, it's taking that query, giving this, putting this into the context window too, to give you that answer. Yeah. Okay, so we take a look at this. Again, to make things simple here, answer in 10 words or fewer. I think I also put this in with Pi 3, only answer the question. Again, this is where I talk about, this is more art than engineering when you start talking about the actual prompts themselves. Because one of the interesting things that I found, it would start going off on weird ass tangents. I think especially with Pi 3, so you give it like the last 10 memories, and then it'll just grab memory number 5 and just start going off on a tangent. And you're like, what are you talking, what? I don't, yeah, so anyways. Okay, so we come down here basically to the while true loop, as we had before. So input, how can I help you? Memory equals db.remember. So basically this is going to be what the memory is. I'm going to come up to the database class. I'm going to go to remember. So what this is going to do is we're going to say select all from memory limit to 10. So all that's going to be is essentially the last 10 records that have been created. This number can be whatever the hell you want it to be, right? You can define it different ways. We're going to execute that. We are going to fetch all. Then we're actually going to create a little memory value here for the string. We're going to do query value 0, response value 1. And so that's going to try to give you, again, you're giving the LLM, you're trying to give it some information to answer in the best possible way. And that's going to get returned back, and that's going to be your memory, right? So the full query then, you're going to say, answer this query. Here's what the query is. follow these rules, whatever the injection is. So again, these rules could come from the database too. And then this is our conversation until now. Again, you're trying to explain what the hell's going on. You're going to give it the memory. Response equals query full. So this is the full query. Then database.new, query and response. You'll notice here I say query full instead of simply changing the query value. So I have query full. So this is going to be everything. But when I add memory to the database, I don't want to add the entire memory to the memory database every time I do this. So that's why when I go and insert into the database, I just want the clean query with the clean response, right? And then I print query and response out onto the screen. And so that basically gives you the idea of how to start creating a memory. Any questions? No? No. So that's memory for you. Then we start getting to the last couple. I think it's last two examples. This is where we start getting into images. Let's see here. This is the pick gallery, right? I just want to do this right. CSV, open. Open new path, query response lava. Yeah, pick. Okay, let me just, oh no. Create table picture. Yeah, okay, let me just drop a table. I have to make sure what I'm doing here. Okay, so tables. So this is where you have to be very careful. Drop table picture. And just so you understand how SQL works, that table is now gone. I had a buddy of mine, so there's a whole thing going on right now. Was it 996? If your boss starts talking about 996, quit now. I guess in the tech world, I don't know, there's this idea, hey, we've come so far, let's work like Chinese people do. So there's this idea we're supposed to be working like hundreds of hours a week. It's dumb. If you are new to the tech world, don't do it. Our brains work for about 40 hours a week, that's it. And the reason is, I had a buddy of mine. So when I worked at the first corporation, we had a 9,000 person company. We dealt with God knows how many customers. And so this was back in 2000. So we rolled our own CRM solution. And when I mean we rolled our own CRM solution, like we were using fucking like Oracle, like entire racks of servers as our database. Anyways, we were doing a migration and we used Unix in the day. And so one of my buddies was one of the main Unix administrators. And so they had this rack of Unix databases and they're migrating from this rack to Unix databases to this rack of Unix databases. Anyways, we were using planets for our naming convention for some reason. And anyways, the new rack of databases, it would cluster whatever, is called Jupiter. That was the server name, Jupiter. And the old one was Saturn. So they had spent the last month migrating from Saturn to Jupiter. She had been working 100-hour weeks for a month. And so the final thing was simply to decommission the old server. And she said, it was hilarious to look at her face. She was like, I even fucked up the command originally. So she typed in like delete whatever it was for the server. And she was like, delete. And then she plugged in the new server, Jupiter. Because the last 4 hours, she had been verifying that Jupiter was correct. So when she typed, right? And she literally even says she fucked up the command. Like not the name, like a comma or something, right? The fucking term, it failed her out and said, command, right? She was like, oh, fuck. So she retyped it in perfectly and fucking wiped out the Unix server that quick. Yeah, I was doing support at the time, and that was just absolutely miserable for us. And the worst part is, just to understand how the tech world really works, she wasn't even fired. Like her manager literally looked her in the eyes and said, shit, take a few days off, we'll figure it out. So yeah, the thing to be careful about when you're dealing with the databases themselves is as soon as you drop a table, that damn thing is gone. That is why there was a story recently in Ars Technica and many other places. There is a CEO of an SEO company. I can't believe this guy admitted to this, right? He's a CEO of this multi-million-dollar SEO company. He was vibe coding. He was whatever. He wants to vibe code. He's using Replit, whatever. Not my thing, but he's wants to do. Anyways, he was using Replit, and apparently it was connected to the production database. Literally, he told Replit to do something, and Replit wiped out the production database. And he then went to Ars Technica to cry about how bad Replit was. And you're like, whoa, dude. No, you just shut up about that and go home and drink a 6-pack of beer and come back tomorrow. You don't tell anybody you did that. So, anyways. Well, you understand, when you're dealing with the database, be careful, because things can get bad really quick. So anyways, okay, so with this, we're going to have two things. So the idea here is we have a pictures folder. And in the pictures folder, this is something that you may have, again, within your organization. This is something that you can probably try to sell. Think about this. For your PR, for your HR, for your marketing team, we have had digital cameras for 25 years now. They have been taking thousands of pictures a year for 25 years with what's called taxonomy. We talk about taxonomies, that's tags, descriptions, that types of things. So they have terabytes of images and no way to know what the hell to do with them. Right? And so basically what I did here is I just did screen capture to make this easy, and I went through and I just did a lot of screen captures of different food products right here. And so what we're going to do is we're going to use Ollama. There is the Lava, it's called the Lava model, and the Lava model will go through and it actually can view images, and you can basically make queries and it can give you a response. So what we're going to say is go through this folder, open each image, create a description of this image, dump that into the database, and then we're going to create a bottle web app script that is then going to create a gallery for us, and then we're going to be able to search through and look for images that might be useful. So if we go through and we take a look at the first script, the big thing here, and again, this is something you have to be thinking about, like with architecture and design, is that these are two different scripts. So we have one script that is going to search through the pick folder and basically add everything into the database. And then we have our bottle web app script, and that is what we're going to be using to actually be able to look at the gallery. So we have the SQL image here. We have SQL image, there we go. Okay, so we're gonna go here. So there's no while true loop because we're not actually asking any questions here. So pictures equals, so this is going to create a list. So we're going to use this module for OS. So OS up here. Oh, you're leaving us already?
Sorry.
Ah, no worries. So we're going to use this function called list directory. And so basically it's going to take all of the images in this particular folder. It's going to add those to a list called pictures. We're simply going to loop through. We're going to say for name in pictures. Response equals AI name, so we're going to send that name to the AI function. If we come up here, we take a look at the AI function. So what we're going to do here is the query is going to come in, or the name is going to come in. We're going to do model lava. And then here is basically the prompt we're going to give. So describe this image, specify each food product, include any brand names, include the nationality of the food. Again, Mexican, Italian, that type of thing. Images, and then F string, pick, and then query. So basically, the image is going to be in the picture folder, and then that value that's coming in here. So again, that's just where you have to have the file structure, and it's going to go through, and it's going to do that for each image. We're then going to go to database new. We're going to come up here to database. We're simply going to go to new here, insert into picture, path, and description. So the path and the description, the values, path and description, and then we're going to close. And so basically that's all we've got for this particular one. So if I run this, it should now start adding this to the database. Now, again, we talk about how we go from 10 lines of code to 1,000 lines of code. You will notice in this code, there's no validation to verify that the image isn't already in the database. So think about this. So if I added images to the database and then I run this script again, it will then add another 20 records and another 20 records and another 20 records. So then if I say taco, I'm going to get like 50 of the exact same image popping up. So that's where you have to be careful. So it's going through, and again, this is just giving me like a little user interface to say, okay, that screenshot has been processed, that screenshot has been processed, that screenshot has been processed. We can go to the database. We can do select all from picture. And we can see, right? So it's has the image, and it gives you all this stuff here. We select again. You can see another value has been added. Another value has been added. Yeah. And so it's going through and it's processing all those images. So give it a second. Any questions on this part of the code? Yep.
The LLM, it's adding that description of the pictures that you created into the database? Is that what's happening?
Yeah, so, well, the LLM isn't. So what's happening here is if we just, because that's actually processing, right? So response AI, so we have the AI function here. And so basically we're sending the picture value. We're saying, do all of this. So here's the picture. So in this folder is this picture name. I want this information about the picture. Describe the image, specify the foods, blah, blah, blah. This is then being returned. So the value that comes back from this is being returned as the response. So then what we do is we do name. So that's basically the picture name plus the response. That's being added to the database. Yep. And then we're just printing out this little processed on the screen just to show us what's going on. And now we can see it's finished. So now we can go to the Bottle app. So Bottle image. So basically what we have here, so for the new people here that haven't seen this before, Bottle is a web app framework. This basically allows us to use Python in order to create a web application. We use Bottle here in class basically because of this function down here. I can literally simply click run, or I can run the script and the web app runs. Yeah, so they're all similar. So Flask, Django's great, but it'll take me a day to explain that to anybody. So basically, with the idea with Bottle is it's a micro web app framework. So it's it gives you the least that you need to actually build something.
So the naming conventions, Bottle and Flask are like.
Oh. Yeah, Flask is also small. You know how it is in the tech world. Somebody builds something new and then different people use it. The reason I like this is I don't have to call it externally. Basically, all I can do is I hit this run button, and you can see here, just to show you. So I click on this, right? And so it gives me the web app, and so I can say taco. Oops. I can say taco, I hit submit, and now shows me all of the images with taco in it. And it gives me all of these. You don't have to do this, but it gives me the description so I know what it's firing off of. I can do Coke. Oops. I can do Coke. No Coke. I can do cola. That shows me all the cola. That's the other thing to be thinking about too, again, when you build these taxonomy systems, is remember, it's going to be responding with what it sees. So is it Coke or is it cola? And again, that's where you can build additional like thesaurus type systems to try to figure that kind of stuff out, right? So this is showing me different things. I can do, let's say fries. And so it shows me everything that has fries in it, right? So now again, imagine if this was 100,000 images, it now gives me some ability to try to sort through all of those. If I go and I actually take a look at the script itself, this is the route. So basically, we have Bottle up here, run, route, post, request. We've done these before. Again, we're gonna have a class on this to explain this better. But there's also this function here called static file. One of the important things to understand when you're dealing with Bottle web app framework, again, any of these web app frameworks, whether it's Bottle, Flask, or Django, is all they want to be giving to you is kind of like the HTML, the code. From a security standpoint, they don't actually want to be delivering the files to you. Again, we talk about architecture. When you're dealing with this kind of thing, your file store should be somewhere else. So you should have a bucket on AWS or a bucket on Azure or a file server that's dedicated to just being a file server. Remember, every feature a server provides is a vulnerability. The more features you put on one server, the more vulnerabilities that server has. So what I have here is not really what you should put in production, but this isn't production. So there's something called a static file function, and what this does is down here, this allows us to serve files from the local computer. So this is a weird thing. Like, so if you use Apache, or Nginx, you can just simply dump the images or whatever into your default folder, and you can access them because that's how their web server works. If you don't put this static route in, you won't be able to get the static files off of your own computer. Even though it's even on your computer, they simply will not be provided to you. So that's where this static function comes in. So anyways, so basically we have this route here. So we have method, get, and post. So query equals request forms.get, the query name. So we have this form down here. Right, where is my form? We have this form. So the form, we take a look at the page, right? The form is this thing up here. Anyways. So this is the form up here. That's that. And this is the form here. So page, web app, form action. Method post, the query name. So basically what we're putting through, right? So query equals this. Response equals db.findQuery. So it's going to look into the database for whatever that query is. We go to find. You can come up here. We go find. So the query that comes in. Select all from picture where description like, question mark. And this is where we have the appropriate wildcard F string here. So again, these are wildcards on either side, the query in the middle. So if you put CO, anything with CO should pop up, that type of deal. All right, so that's a response that's gonna come back. Gallery equals, and this is where it gets ugly with, you know, basically trying to create this gallery. Oh, you get into div boxes and CSS. Oh my God. Anyways, this is fun. If you haven't played with CSS, you just don't know misery yet. It's just, so anyways, go with me. So here's the guess. So the gallery we're gonna be creating. So basically what's gonna happen down here with page, right, is we're gonna have this form here, and then we're gonna concatenate the gallery in. But we gotta create the gallery before we can put that in there. So div, we're gonna create a div box, display equals flex. And so what we're doing here is you see how all these boxes are side by side? Oh my God, this is so much harder than it. You're just like, put the boxes side by side. Yeah, have fun with that, it's CSS. Anyways, so the big box is a div big box. The style is gonna be flex, we're gonna wrap, so it wraps around, we're gonna try to justify the content, whatever. Then so for item in response, right, we're gonna go through. We're gonna create another div box. The border is gonna be 1 pixel black solid. So that's what we're talking about here. So there's a div box that goes around all of this, and then there's a div box for each item, and that's where we have this particular border, right? So we're gonna say border, 1 pixel black solid, width of 200, image. So then the image that's gonna be in there, we're gonna say width of 200, height of 200, so it's gonna give us that square. And then the SRC is gonna be pick, and then we're going to do item 0. So item 0 is going to be the image name itself. Now again, so since we have pick here, what happens is it goes down to this function and sees pick with file name. So whenever it sees pick, so it's gonna go to that folder, look for that file name, and then it's gonna deliver that. Again, this gets a little bit more complicated. We'll talk about in a different class. And then we're gonna close the div, and then we're gonna close the div down here. Basically then, again, we have the form as it is here. We add the gallery, and then we return the page. So the entire page is now being returned to your web browser. And that's where, again, when we hit run, we hit control, that's where we have this, right? And if I do nothing here, so I hit submit, this will actually show us all the images that I have currently in the database. And again, so I can sit here and I can say, is there anything with onion? And so those two things have onions in them. That kind of gives you an idea of something you might be able to build. Yep. Any questions with that particular one?
Could you also use the AI LLM to get data such as calories, readings, not just from the images?
Well, yeah, so you can't. So that's where there are some 18-year-olds out there, God bless them, they made like $20 million already. So again, with these LLMs, they know specific information. So if you give it an image, if it can determine the portion size of the image and somehow it knows the calories, you might be able to get that to happen. So that's what these kids did. And again, they're 18-year-old kids. And that's one of the things to understand with technology and making money. You just got to figure out the idea at the right time. Literally, when OpenAI's API came out, they were like, hey, what if I could use my smartphone, I could take a picture of my plate and it could tell me the calories. And yeah, the LLM was able to figure out the portion size, and it figures out the specific calories for the portion size. And now it's like whatever, I don't know, one of these things, basically just an automatic calorie counter for you. So yeah, so basically you can't do that. You just have to find the LLM. Again, you have to find an accurate LLM too. You know, you don't use Pi 3 for that. You know, it's like, oh yeah, 3 hamburgers and onion rings, that's 5 calories. You're fine. You're like, oh no, that's, yeah, so, yep. Okay, so that's that particular app.
Is this only for JPEGs or PDF? Can it be any visual? Or again, depends on the LLM?
Yeah, so basically when you go to search, so again, so this is running Ollama like we've done. So we put in Lava. So this is the Lava framework, and that's where you can click on this, and it will tell you,
Right there, Vision Assistant.
yeah, no, but it will tell you,
Size.
it says somewhere, I don't know, GitHub. Somewhere it says. It's like PNGs and JPEGs, and again, that's where, like I say, you do the where you're like demo. Yeah, it gives you a whole bunch of information here. So yeah, I'm not sure where
it's
it's
not
at.
dependent on what you're coding, it's just dependent on the LLM.
Yeah, the LLM has to understand what it is. Yep. Again, and that's where I also say again, as a quote unquote real professional, most of your time is looking at documentation. You're just doing a checklist. You're like, okay, what are the things that I care about? Do the checklist. Okay, so the next thing and the final class, final part of this class is a photo gallery, an OpenAI photo gallery with taxonomy. So one of the things we talked about before, so the last class we did here was using the OpenAI's API. And the cool thing with that is you can use something called DALL-E. And what DALL-E does is it does image creation. So let's say you plug in a big old prompt and you want it to give you an image. One of the things I showed you folks before is that, do remember, DALL-E on its own, it will give you the URL. So it'll create the image, it will dump the image into a bucket on Microsoft Azure, and that URL will last for 1 hour. No longer than 1 hour. 61 minutes, the URL gets deleted and your image goes away. So one of the things I showed you folks before was basically how to download that image so that you can actually store it. So what we're going to be doing with this photo gallery with taxonomy is we're going to be creating the images. We can create the image from the web app. And then what happens is the image and the description get saved. Well, the image gets saved into a folder. The path and the description get saved to the database. And then, so now every image that we create also gets saved, and then we can do a search for it in the future. One of the values for this, one, is again, if you're with a company that's creating images, it means the damn things are actually saved. Again, imagine if your marketing person comes up with the best image, and then it disappears in 61 minutes. And then they spend the next 5 days trying to recapture that image, right? So this way, it just automatically saves the darn thing. And the other thing to be thinking about is, again, remember, from a business standpoint, if you're using DALL-E, every time you run that query, it's 4 cents. Again, not too bad. Again, you got 100 people in your marketing department running that damn thing all day. Wouldn't it be nice to have a caching system? Hey, maybe we've already got a dog eating pizza. Maybe we can just already look at that one, right? So that's basically what we're going to be doing here. So with this, it's actually all one app, because it's doing its own thing. So if I run this, I can hit this, I can hit send. Okay, so all these are the images that I've created so far. And again, if you notice, I'm really weird with my images. We have a pizza eating a taco. We have a hot dog fighting a taco. We have a taco eating a pizza. All these are the kinds of images I created. But it is cool. Again, if you'll notice, DALL-E is actually pretty impressive. So if I come here and I can say create an image. So if I come up here, you can see this. So I'll do a create an image. So I'll do a hot dog eating a pizza. And I hit enter. And we come up here and we can see this thing is processing.
process. A little comment, I attended a conference yesterday morning.
Yep.
The IP said you cannot, anything that is created using LLMs, you cannot register or try market at all because it's
It's a
using.
big fight right now.
Yeah,
Yeah.
but so far the lawyer said you can't.
Yeah, that's an argument over quite a few six-packs of beer. Yeah, that's its own. That's its own discussion. Anyways, so okay, so I have here a hot dog eating a pizza. So whatever this is, and then it gives the description. So one of the things I talked about with OpenAI that's really cool with DALL-E right now is it creates a revised prompt. So the nice part with me, again, I'm a programmer, I'm a geek. I don't really like this whole prompt crap. So again, I put in a hot dog eating a pizza, and then it actually creates a whole story for me. So it'll then create the image based off of this story, not just simply my prompt. The valuable part with this too is this also gives me wonderful taxonomy. So I'm getting not just the image back, but I'm getting that revised prompt. So I can save that as something to search off of. So then I can come up here to search for an image, and if I say just...
So you've already pulled the image down now?
Yeah, so as soon as I do to create the image, so this has been stored into my static folder, and now I'm pulling it from here. Yep. So now I can do something like search for cat, and when I search for cat, it shows me everything where I have a cat, right? If I do a search for pizza, it shows me everything that I have pizza, right? And again, with this exceedingly simple search mechanism, you can spend the time writing 500 lines of code to make a better search mechanism. If we go and we take a look at this, just to give an idea of how this works. Again, we start to have more and more and more and more stuff going on. Okay, so we have OpenAI, so we need OpenAI for this. So we're going to need that Open API key. Again, you just need to go do it. We have the bottle stuff here. We have SQLite. We have requests. So this is a module. You do have to install this module for Python. This is what allows us to actually download that file, right? And then I use a time module here. This is a simple thing that I use, simply for file names. Basically, when you download a file, it doesn't just naturally keep the name. You have to give it a name of something that is unique. And so I just use a time code. That's what I do. Then we scroll down here. Again, we have the static route. As we've had before, we have this to pick_OpenAI. So that's where everything is going to get downloaded to. We have the DB create. So again, do remember to create your database just to make sure it's there. And then we have run. When you do see this, so it's going to run on local host. So that's 127.0.0.1 on your web browser. It's going to run at port 8080. So the default port is 80. Most of these systems lock that out for administrative purposes. So it's going to run it on port 8080. Just kind of keep that in mind. Okay, so we go here and we take a look at this. Query create. So that's going to be the create query. If we plug that in, so query create or query search. Current image equals nothing. So we're going to say here, if not query search, query equals nothing. Image gallery equals gallery query. We're going to come up here to the gallery function. This is where we get to. So pictures equals db find. So we're going to come up to database. We're going to find. And we're going to find basically nothing. So if there's nothing in there, it's going to show us all the images. So select all from picture OpenAI where description like. It'll just be a space. So it should be everything should come up. We're going to fetch basically everything, right? And then we're going to come here and we're going to print out the gallery. And this is where, again, we get into CSS and we get into div boxes and the whole funness. The big thing here is, remember, we're going to pick OpenAI instead of just simply pick, and we're going to return the gallery, right? So if not query search, we're going to basically return the gallery as everything there. If query create, response equals AI query create. We're going to come up to AI. And this is now going to be the OpenAI query. Again, this is one thing to be thinking about with things, it's called SOA, Service-Oriented Architecture. When we're building our systems, we're connecting to resources, not servers. So what I can do here is, let's say I'm currently using OpenAI in order to get the images, and that's fine. And then the boss says, oh my golly, this is expensive. Why don't we just buy our own server or something? You might buy your own server, create that to provide services, and then simply change this function to call your own server instead of OpenAI. So that's one thing with service-oriented architecture. We have our key here. This is not how you're supposed to do the OpenAI key, just so we know. We talked about that in the other class. This should be an environment variable. But again, I'm showing you this, folks, simply. So key equals client. Client equals OpenAI, the OpenAI function. API key equals this particular key. Again, this should be an environment variable. That's its own world. So the result equals client.images generate $E3. We want this size. The query is going to come in. So prompt equals the query. So $E3, this size, the query. Image URL basically is going to equal the URL that's going to come back. And revised prompt is going to be the revised prompt that comes back. We're going to return the URL, and we're going to return the revised prompt. And if we come down here then, let's see here. Image URL is going to be response 0. So that value that came back from response is going to be at the 0 index. The revised description is going to be at index 1. We're going to do file name equals download an image URL. So we're going to go to the download function. So image data equals request.get image URL, the content. File name, this is where we're going to use that god-awful timestamp in order to create a file name and add PNG to the end. And then what we're going to do here is with open into the pick OpenAI folder, that file name that we created, write in bytes as handler write image data. So basically the content of the image is going to be written into this folder as this file name as bytes. Or as binary, I suppose, as binary. And then we're going to return what the file name is. So we're going to download we're going to grab the contents, we're going to save the contents as that file name, and then we're going to return the file name. We're then going to come here, db new, we're going to send the file name plus the revised description up to the database class for new. And basically we're just going to insert that into the database, into the picture OpenAI table. All right. Let's see here. Past that, for current image, so this is create the current image. When that comes in, we're going to show that. So image style, so height 400 pixels, width auto. That's where we just see that ugly image there. And then we're going to put the revised prompt underneath. Elif query search. So if there is a query search, image gallery equals gallery plus what the query search is. So basically, if it's instead of create, it's query search. We're going to go here for the gallery. The query is going to come in. So taco, pizza, cat, that's going to come in. We're going to select only taco, pizza, cat. We're going to create that gallery. We're going to come down here, else current image equals nothing. Then we're basically going to create this page here. This is the form. So this is the form. This is create the image. This is search for an image. And then we're going to say, so basically here, the query for create or the query for search, this is just an ugly way of doing it. So if there's a query for create, it will show up. If there's a query for search, it will show up. It'll show the current image, and then it'll show the image gallery, and that's going to return the entire page. I hope that makes a damn bit of sense. I'm not sure I remember that. Anyways, do you kind of sort of get what's going on? I mean, do you feel like you can go home and read the code and you have an idea of what's going on? That's the big thing there. So anyway, so that's the idea of what's going on here. So if you do create the image, it's going to create the image. It's going to download and save the image as a file name. It will then save the file name and the revised description into the database. It will then show the image on the screen, and it will show the revised description along with the gallery underneath. If you do search, it will search for any records in the database that are like what you're asking for. It will then simply create a gallery based off of that and show that onto the screen. That's a simple way of explaining however many lines of code we got here. Again, do you makes sense there? Yeah? No? No. Okay. And so yeah, God help us. That is the class for tonight. 2.5 hours there.